Integration by parts is usually a very straightforward method. All you need is this formula, and using these two functions that I'm applying each other, you find your f of x, or you choose your f of x, your g prime of x, your f of x, your g of x, f prime of x, and g of x. You simply substitute into this formula. That's what you do when you're doing integration by parts. And last time I did a video where I was explaining a situation where you do successive integration. In other words, you apply integration by parts twice or thrice. That was a different situation. In this case, we are going to have a recurring integral. And usually when you're given a question, you should be able to see if you're going to do successive application of integration by parts, or you're going to have a situation of a recurring integral. This is the hint. If you have two functions that if you differentiate them successively, they don't dissipate into a constant. If you have two functions that upon successive differentiation, you don't get a constant, you are going to have a situation of a recurring integral. If we take, for example, e to the power x, if we choose e to the power x as our f of x, if we differentiate it to find f prime of x, we still get e to the power x. If we choose cos x as our f of x, if we differentiate it, we get minus sine x, which if we differentiate again, we get minus cos x. So it keeps recurring. It doesn't go away. Once we have such a situation, we are going to have a recurring integral, and I'm going to explain how you deal with that situation. So let's start. I'm going to choose e to the power x as my f of x. So e to the power x is f of x. E to the power x. So f of x is equals to e to the power x. Let me use a different pen. F of x is equals to e to the power x. This means f prime of x is e to the power x. That's the first derivative of e to the power x is e to the power x. Then my g prime of x is cos x. This means g of x, which is the antiderivative of cos x. In other words, you integrate cos x to get g of x. If you integrate cos x, you get sine x. Once I have f of x, f prime of x, g prime of x, and g of x, all I need to do is to substitute into my formula. So that is the next step. Let us substitute into the formula for integration by parts. I'll rewrite the formula, and then I'll substitute these. So the formula says integration of f of x, g prime of x dx. This is equals to f of x times g of x minus the integral of f prime of x times g of x dx. My f of, so this means e to the power x, integration of e to the power x cos x dx. All I'm doing now is substituting my f of x, my g prime of x, and my into this formula for integration by parts. It may be given in different formats, guys. You may find it in different formats. Don't be confused. This is another good format that you can use also for the formula for integration by parts. F of x is e to the power x. G prime of x is the integral or the antiderivative of cos x, which is sine x minus integral of e to the power x, the derivative of e to the power x is e to the power x times sine x dx. This is our first step. But we see that we still have a problem here. We have to apply integration by parts again. Now, let us choose e to the power x as our f of x. So e to the power x, f of x is equals to e to the power x. This means f prime of x will be e to the power x. And g prime of x, it is sine x. This means g of x, which is the antiderivative of sine x, or the integral of sine x. If we integrate sine x, we get minus cos x. So this is minus cos x. Now we have to substitute back into this equation. So we still have integration of e to the power x cos x dx equals to e to the power x dot sine x minus, I'm going to put brackets here, f of x is e to the power x. In other words, I'm now applying integration by parts of this part here. That's what I'm substituting here. The integration by parts of this part here. I'm just substituting it here again. I'm using a square bracket here to ensure that I don't get lost, or I don't lose track of my signs. So this is e to the power x times minus cos x, obviously, minus integration of e to the power x, which is my f prime of x, times minus cos x dx. I close the bracket. If you look here, you still have a problem again, because this part here will still require integration by parts. However, this is where you should pay attention how I'm going to deal with this. Now let me simplify this whole bracket. I have e to the power x sine x. Guys, there is a minus sign here, and there is a minus sign outside here. So this whole term is going to be positive. So this is going to be plus e to the power x cos x. Now I have a minus sign here and a minus sign here, which means this whole thing here is going to be positive, but we are multiplying it by a negative sign outside. It means we are going to have a minus in the end. So this is minus integration of e to the power x cos x dx. This is what we need. Look guys, this part and this part, they are the same. This is the recurring integral I'm talking about. The integral of e to the power x cos x dx. It has come back again. We have it here, we have it here. All we do now is to combine these two integrals. We don't have to do integration by parts again. We stop here and we combine the two integrals. So I'm going to rewrite this whole statement here and then show you how you combine the two. So let me clear my board and rewrite this again. So I have integration of e to the power x cos x dx being equals to e to the power x sine x plus e to the power x cos x minus integral of e to the power x cos x dx. I'm going to apply ordinary algebra here, which means I'm going to shift this to the left hand side. I'm going to add these two integrals together using the ordinary rules of algebra. So this will be integral of e to the power x cos x dx plus integral of e to the power x cos x dx. This is going to be equals to e to the power x sine x plus e to the power x cos x plus a c plus a constant. If we add these two, we get 2 integration of e to the power x cos x dx being equals to e to the power x sine x plus e to the power x cos x plus a c. But guys, we're looking for this only. We're looking for this only. So to isolate that, we divide by 2 throughout. So divide by 2 throughout. This is our final step. We divide by 2 throughout. Now, if we divide by 2, we are left with the integral of e to the power x cos x dx being equals to half e to the power x sine x plus half e to the power x cos x. If we divide the c by 2, we get c over 2. It is still a constant, so we don't have to write c over 2. We just write plus c. This is our final answer. So in this situation, we applied integration by parts 2 times. However, we still had an integral that was similar to our original integral. In other words, we had a recurring integral. And once we have a recurring integral, we combine the two similar integrals together using the ordinary rules of algebra. And then we simplify until we come to a final answer like this. This is the answer. This is how you do it. You should at least have a way of predicting this situation. All you have to look at is, if you look at the two functions that are multiplying each other in your integral, like the e to the power x and the cos x, both of them do not dissipate upon successive differentiation. Once you see that, you are going to get a recurring integral. You're going to get the situation that we're dealing with now. But if we had an x squared and a cos x, we were never going to get this situation, because the x squared, if we choose it, is our f prime of x, is our f of x. It is going to dissipate upon successive differentiation. And all we can do in that situation is maybe to apply integration by parts 2 times or 3 times. That's all. But in this case, we are going to have a recurring integral, and we combine the two similar integrals together using the laws of algebra. Then we simplify. That's our final answer. I hope it was quite straightforward. If you have any questions or if you need clarity on anything, just comment in the comment section below. I will respond. Otherwise, subscribe to the channel, like the video, and share with your friends. Thank you.